So welcome to this live session on the course on basic principles and calculations in chemical engineering. I welcome all of you. So if you have any doubt regarding this chemical engineering course on this special MOOC course on basic principles and calculations in chemical engineering. In this course, I think we have given 12 modules, and these modules contains 3 lectures, and these lectures given for a specific topic based on which you can assess yourself for the strength of chemical engineering knowledge. This is very basic course in chemical engineering process, and I think till now whatever courses, whatever actually the lectures covered, I think you have already gone through. And for that, if you have any doubt on that, you can write a mail to me, or in this live session you can also ask. So in the very beginning of the course, I have given some introduction on chemical engineering calculations. But before that, I also actually described about the role of chemical engineering, definition and history of the chemical engineering processes there, and we have given the flow of chemical engineering when it actually begins to come into effect, and also how it is being actually used from the beginning for the welfare of the human being. There we have given some connection of that chemical engineering processes, the basic calculations and processes depends on what. This chemical engineering process basically multidisciplinary process which is connected to other that sciences like chemistry, physics, mathematics. All those courses are connected to this chemical engineering processes. Without fundamental knowledge of those basic sciences, you will not be able to understand the further process calculation in chemical engineering field. So I think you have already gone through those science which are related to that chemical engineering process. Yes, yeah, others Pandey that you have asked. Good evening. That yeah, there is a career options in chemical engineering. Okay, I'll just give the smell of that career in chemical engineering in this lecture. Okay, just see how that chemical engineers can act different activities, not only here in the strict field in chemical engineering processes, but the chemical engineers, based on their knowledge, they can give their contribution to other streams also. Now you will see that in the first lecture number 1, yeah, Mr. Pandey, I think you have gone through that first lecture there. the role of chemical engineers and how they are involving in different activities as a chemical engineer, and their activities goes further ahead beyond this chemical engineering, that I have given that examples also. uh, Starting chemical engineering is really interesting, but before starting that chemical engineering, that you have to know the definition of that chemical engineering. So they are basically no universally accepted explanation or definition of the chemical engineering at its starts, but later on it was defined based on the preamble. And this chemical engineering then can be defined as this is basically the area of applied science that puts to use physical, chemical, and biochemical rate processes to produce essential chemicals and articles for the betterment of human uses. As per dictionary, you will see that chemical engineering is defined as this is a branch of engineering which involves the design and operation of large scale chemical plants, petrochemical refineries, and the like. Now, see, large scale chemical engineering plants, they are anywhere. You go to the petrochemical industries where different types of hydrocarbons are produced, refining of crude oil, the chemical engineers can play a vital role there. Without chemical engineering process knowledge, there that process cannot be run, because there that in every aspects, in every that operation systems, that process involved. Now for that process you have to know different aspects of that processes, like what is the input, what is the output, what is the material balance behind that, how that equipment can be designed based on that chemical engineering process, what is the fundamental behind that, and from that fundamental basic science, that how you are implementing that science to scale up those chemical engineering process in industrial scale. So there the basic knowledge is given to that chemical engineer, and that chemical engineer can handle all those process engineering, where crude petroleums can be refined, where nowadays that only not only that crude petroleum, nowadays process intensification in every aspect, the old chemical engineering processes, where you will see that the intensification of the process nowadays is very that required. The conventional process nowadays given very that uh, energy consumed process, but you can that intensify that process to get that less consumption of energy, based on less consumption of energy, environmental economy, environmental friendly, and more economic of that processes. But how to do that? There are several actually way to do that process intensification. Nowadays nanotechnology is coming. Based on nanotechnology, based on surface area modification of the multi-phase systems, based on the interfacial area of the catalyst solid particles where that chemical reactions happens, especially for, you will see that for hydrocarbon production from the synthesis gas, and then its upgradation, that depends on that particle size. Particle size, if you are reducing that micro to nanoparticles, you will see the more interfacial area will be produced, and based on that activated surface of more intensified surface area will give you the better yield of that process. So this is one process intensification. Some process will be green synthesis, some process will be, that other surface area production like micron size, bubble, gas liquid reactions there. So in this way, there are several, aspects are open to, intensify the process, and those things can only do by that, that chemical engineering. So chemical engineers. So as a chemical engineer, you can roll on that. Okay. Uh, yeah. What is that? Yeah. BZ Wazirable M. Yeah. Can you explain the question number 9, 15, and 18 assignment number 2? Yeah. We'll give you the, that explanation for that 9, 15, and 18 assignment number. Okay. 2. Okay. I have noted it down. Yeah. So I'll give the clarification. Can you please put these questions in your forum also, so that we can answer this. Okay. Okay. Uh, can you give one white paper or something? So there. Okay. I'll put it down and I'll clarify this. There are question number 9, 15, and 18 in assignment. Okay. So what we are discussing, that the definition of the chemical engineer. As per information highway, this is basically the global information and communications network. The chemical engineering is defined as uh, the chemical engineering is concerned with process that cause substances to undergo required changes in their chemical or physical composition, structure, energy content, or physical state. There are other, several definitions of that, that chemical engineering. Uh, Branch of engineering which deals with the, that application of the principles of economics and human relations. And in this case, you will see that to feel that you have to, pertain that directly to process and process equipment, in which matter is, treated to affect a change in state, energy, even you can say that some, based on that composition of that, reactant, those are used for that synthesis processes to get the valuable product. So this is the definition. And chemical engineering process, you will see that there are several different processes where you can say that those processes will be based on the, different operating variables. Suppose in a particular reactor, the reaction is going on. Now you have to maintain certain temperature, certain pressure. You have to control the flow rate. You have to, design the reactor in such as the specific diameter of the, reactor, volume of the reactor, and also there are some other controlling system that you have to, take into account. And then you will see that yield will be depending on that different operating variables like this. Like example, I know one example, like suppose you want to remove the carbon dioxide from a gaseous mixture, and that can be done in a chemical engineering process. You can separate that carbon dioxide gas just by absorption. Now that absorption can be done in a reactor. Now there you will see that absorption will be based on the solid flow rate, liquid flow rate, or carbon dioxide gas with other gas mixers. Now in that case you will see that in a particular reactor, if you supply this gaseous mixture where carbon dioxide and other gases to be there, and if you pass it through a reactor, there you have to pour a bubble. That means gaseous mixture to be distributed in the liquid as a dispersed phase of bubbles. Now that bubbles will form the interfacial area between gas and liquid. Now through that interfacial area, carbon dioxide gas to be, passed through that interface to the liquid. Now you have to select a liquid in such way that that liquid can absorb that gases, like sodium hydroxide solution or amine solution. You will see that if you pass that carbon dioxide gas through that amine solution, you will see that carbon dioxide gas to be absorbed by that amine solution. Now in amine solution, if you pass that carbon dioxide as a dispersed phase of bubbles, you will see that there will be formation of carbon dioxide bubble, and that through that interface there will be a transfer of carbon dioxide to the liquid. Now formation of this interface, this is the chemical engineering. Chemical engineers can that control that interfaces, so that you can get more mass transfer, more carbon dioxide transfer from gaseous mixtures to the liquid phase. So here chemical engineer can do. Okay. So in this case, that from this concept that chemical engineers can apply in other way to get the other different processing. Not only here, you can see that I think you have learned that Fischer-Tropsch synthesis in your chemistry. Now this Fischer-Tropsch synthesis, you know just what is the way of synthesize that. But to produce that different hydrocarbons by synthesis in a continuous process from a source, how chemical engineers can can give his effort to produce that hydrocarbon. Chemistry knowledge is there. There is a synthesis, that means from the synthesis gas in presence of catalyst particle at a certain temperature and pressure, it will be converted into different hydrocarbons. Now role for chemical engineers that you have to scale up this process in a particular system at a high flow rate of the synthesis gas at a certain temperature and pressure to get continuous yield from that process synthesis. Now you have to then control the temperature, you have to control the pressure, you have to control the size of the reactor, you have to control the flow rate of that synthesis gas. You have to then, what you have to do, you have to separate those mixture of hydrocarbons into its single components. Now this is the role of chemical engineers, where they can separate those hydrocarbons into a purest form, and they can design a system where this synthesis gas can be converted to a useful hydrocarbon. So that is Fischer-Tropsch synthesis, and the process system where this continuous operation can be done, it is designed as a slurry bubble column reactor. So in the slurry bubble column reactor, the synthesis gas is going at a certain temperature and pressure in a cobalt or aluminum oxide, catalyst, and it will be continuously circulating or mixing inside the reactor, so that all the surface of the catalyst particle will be effective for the synthesis of that hydrocarbon from the syngas. So this is the role of chemical industry. So you have to act there. So in the petrochemical industry, where the different hydrocarbons are produced based on this concept, there chemical engineers are required. So you have to work there, or you have to your career will be there. Okay, so you ask that where that chemical engineers or chemical engineering career will be there. Not only here, there are several other options are there. I am coming to that point there. So from the beginning, how that chemical engineering, started there. For all intents of intents and you can say that purposes, the chemical engineering profession began in 1888. I have actually described in lecture 1 there. And the term chemical engineer had been, floating around technical circles throughout the, 1880s. But there was no formal education at that time for such a person at that time. And the chemical engineer of these years was either a mechanical engineer who had gained some knowledge of chemical process equipment, a chemical plant foreman with a lifetime of experience but little education, or you can say that an applied chemist with knowledge of large scale industrial chemical reactions. So at that time that chemical engineers was treated like that here. And then in 1880 you will see that George Davis united different professionals through a society of chemical engineers and proved unsuccessful of that chemical engineering profession. But this model state of affairs was changed in 1888 when Professor Lewis Norton of the MIT introduced a course X. Thereby he united that chemical engineers through a formal degrees. Other schools such as University of Pennsylvania and Tulane University quickly after that followed suit, adding their own 4-year chemical engineering programs in 1892 and 1894 respectively. So see, in 1888, though George Davis was tried to design or develop the chemical engineering professions, but anyway he was not successful. After that, Lewis Norton, he has started in 1888 a chemical engineering professions with a course X. With a course X, it's a 10 courses there, thereby uniting that all chemical engineering to a formal degree. So from then onward, that chemical engineering degree started. And then you will see that 1766 to 1844, John Dalton, you will see in 1805, he published atomic weights, allowing chemical equations to be balanced and establishing the basis for chemical engineering mass balances. You will see that. So in 1824, later on, French physicist, you will see the Sadi Carnot in his reflections on the motive power of fire was the first book to study the thermodynamics of combustion reactions. This is the important, that knowledge which is required as a chemical engineer there. He described the Carnot cycle relating to the theory of heat engines. Now this Carnot cycle in thermodynamics, mechanical engineers that follow, even chemical engineers they follow this Carnot cycle there. Design of that, refrigerator system and others, heat engines. In 1850, he began to apply the principles developed by Carnot to chemical systems at the atomic to molecular scale. After that, you will see that during the year 1873 to 1876, at Yale University, the American scientist made significant theoretical contributions for the study of chemical systems using the thermodynamics of Clausius. Later on, you will see that 1882, Helmholtz, he published a founding thermodynamics paper similar to Gibbs. He also showed that measure of chemical affinity, the force of chemical reactions, which is determined by the measure of free energy of the reaction processes. In 1880, George Davis proposed the unsuccessful formation of Society of Chemical Engineers in London. However, it was not successful, but later on, you know that in 1887, he presented a series of 12 lectures on the operation of chemical processes. Now it is called unit operations. I think everybody will learn that unit operations in the chemical engineering course. Their unit operation course or solid fluid operation course is there. And in 1901, he published a first book in chemical engineering. This is called Handbook of Chemical Engineering in 1901. And that Handbook of Chemical Engineering, you know that is a heap of lot of chemical engineering informations there, based on which later on the all progress of chemical engineering started from his concept. And then Osborne Reynolds, 1883, he defined the dimensionless groove for fluid flow, leading to practical scale and understanding of flow, heat and mass transfer. These are the heart of the chemical engineering, you can say. That without knowing the fluid flow phenomena, without knowing the heat and mass transfer phenomena, without knowing the transport phenomena, without knowing the, that mass transfer characteristics, you will not be able to, assess any chemical engineering processes. So as a chemical engineer, you have to know at least these things, that what is the fluid flow phenomena, what is that heat and mass transfer phenomena, what is the transport phenomena, what is the thermodynamics there. It is required. So from 1883, you know that Osborne Reynolds defined the dimensionless groove for fluid flow, which leads to the practical scale up and understanding of flow, heat and mass transfer. And based on this, all the chemical engineering process scaling up is still going on. Henry Armstrong in 1885 later on offers a course in chemical engineering at Central College. Nowadays it is called the Imperial College of London. And he was the active member in scientific research, and also he has given the concepts of chemistry of naphthalene derivatives, how you can derive different hydrocarbons, okay, from the naphthalene. There is a huge stock of naphthalene from the crude oil, you can see that, and from that crude naphtha which is produced from the crude oil, or sometimes it is produced from the coal sources. From that naphthalene, how you can synthesis different type of hydrocarbons, which is useful in our daily life in generally for fuel purposes. Next, Lewis Norton, he was the professor of organic and industrial chemistry of MIT. He actually started in 1888 a new curriculum at MIT. He also gave the name is called Course X, that is chemical engineering. And later on, this William Page Bryant and his other classmates in 1891, they have been awarded a Bachelor's of Science in Chemical Engineering. Okay, and this William Page Bryant was the first of 7 students to graduate from the course X and thereby become the world's first formal chemical engineer. So you have to remember that how then this chemical engineering profession started, okay, from 1891. In 1905, the University of Wisconsin awards the first PhD in chemical engineering to him. Who is that? Watts. Oliver Peterson Watts. He was the first PhD in chemical engineering. He was a professor of chemical engineering and applied electrochemistry at the University of Wisconsin, Madison until 1937. And he is famous for his, the development of the hot nickel plating bath known as the Watts bath. Okay, so that is why Oliver Peterson Watts is famous from then onward. After that, in 1942, Hilda Derrick, first female student member of the Institute of Chemical Engineers. She was the first female, chemical engineers. So from then onward, you will see that then that chemical engineering discipline was started in full-fledged, and then from then onward, you will see there are different setup of milestone as a distinct profession at 20th century. Chemical engineering began as a distinct profession at the start of that 20th century. Although elements of what are now considered to be core chemical engineering have existed for centuries and more, for example, like fermentation, which is mentioned in that Bible and in Homer there. So the discipline began as something of an amalgam combining chemistry, which is having an industrial focus with the mechanical design and equipment. So the early triumphs which defined that profession in the public eye had to do with the large scale production of essential chemicals. After that 1915, as a milestone one, you can say that fermentation process have existed throughout human history. Now the first industrial scale fermentation process for the production of that octane and butanol through the anaerobic fermentation of corn by the organism, that by the bacteria like that that Clostridium acetobutylate scum, that is discovered in 1950 by the British chemist, that is his name is Wiseman. And the production of this acetone by his root was essential to the British war effort in First World War. That is because that acetone was required as a solvent for nitrocellulose in the production of the smokeless powder, and you can say that calcium acetate, from which acetone was normally produced. So that is why the First World War, this production of this acetone by the fermentation process was important, and that was done only by the chemical engineering process and the chemical engineer. And later in 1930, that fluid catalytic cracking process was developed by Warren K. Lewis and also Gilliland there. And then 1940, these are the milestone that the production of chemicals by biological routes remains a core part of the biochemical engineering. In 1942 to 1945, you will see that there was Second World War. There also that United States was producing 9,20,000 tons of synthetic rubber annually by these chemical processes. And then 1945 onward, you'll see that as a milestone 5, you can say that chemical engineers continue to play a central role in the manufacture and processing of polymeric materials. The chemical engineers of the first half of the 20th century was generally concerned with the larger scale production of chemicals, usually through classical chemical synthesis, but sometimes through biochemical synthesis. And the profession began to expand considerably in outlook during the second half of the century, and from then onward this research, even different process development continued to till date. Now question is that, okay, chemical engineers, they have learned their courses. Now what are the challenges for this engineering, chemical engineering? As per report by the US National Academy of Engineering in 2008, the grand challenge for engineering are: make solar energy economical, provide energy from fusion, provide access to clean water, reverse engineer the brain, that advance personalized learning, develop carbon sequestration, and then what is that, engineer the tools for scientific discovery, restore and improve urban infrastructure, advance health informatics, prevent nuclear terror, engineer better medicines, enhance virtual reality, even manage the nitrogen cycle, even other secure system like cyber space. So chemical engineer needs the active that participation and leadership of these all field. Okay, so role of the chemical engineer student, now where that chemical engineering career can be started there. You'll see that chemical engineers play important role today in every industry and service profession in which chemistry or biology is a factor, which includes that semiconductors, nanotechnology, food processing, agriculture, environmental control, even you can say that pharmaceuticals, energy, personal care products, finance, medicine. Of course, you can say that traditional chemicals and petrochemicals there. So in all those fields, that chemical engineers can play a vital role nowadays. So chemical engineers have traditionally, been involved in both the design of process and the design of products under those challenges. You'll see that role in semiconductor production. You'll see that Andrew Grove, I think you have heard his name. He was selected in 1997 as Time Magazine Man of the Year. Why? Because he has produced, or he has given the production procedure of semiconductors, and he has explained that it is generally driven by chemical engineers who have devised many of the processes for the manufacture of computer chips which are dependent on chemical and rate processes. And Andrew Grove, he's a chemical engineer and he was actively involved in the production of semiconductors. Okay, and he was one of the 3 founders of the Intel Corporation and its CEO, that for many years. So you see that chemical engineer where he can actually contribute. Even role in controlled drug releases. Have you heard the name polymer gels? It is one of the important material that release a drug over time. The issues related to the release, like the solubility of the drug in the gel, the uniformity of the rate of release, and the biocompatibility for any materials that is placed in the body. So one of the leaders in developing these fields was chemical engineer. In that case, Alan Michaels, who was the president of ALJA Research in the 1970s, and he chaired for this, that synthesis of polymer gels and applicability of the polymer gels for the drug release and its control. Then role in synthetic biology, where chemical engineers can, actively, participate. One of the important role of chemical engineers in chemical synthesis that you know. Now, synthetic biology employs the new accesses to the genetic code and synthetic DNA to create novel chemical building blocks by changing the metabolic pathways in the cells, which then function as microchemical reactors. So you will see that in the microchemical reactors, even you will see nowadays that micro reactors it is coming, channel based, micro channel, even nano channel based, reactors are nowadays coming, where this, uh, synthetic biology route to, artemisinin, which is the, medication of choice of that is combating malaria that is resistant to quinone and its derivatives, which can be synthesized by this, that microreactor system and with this microchemical system. Now, as a chemical engineer, how you can participate in the controlling of environment. Like chemical engineers control the environment both through the development of green processes and improved methods of dealing with air and water quality. So chemical engineers, you will see nowadays that removing of different contaminants from the water which is coming out from the industry, which is very hazardous to human body. Now chemical engineers, they are actively doing research how to develop the process to reduce that hazardous material from the outsource of that industry in water. So chemical engineer John Seinfeld and his colleagues developed the first mathematical models of air pollution in 1972. They are also leaders in the development of urban and regional models of atmospheric pollution, especially the processes that form ozone and aerosols. You know that presently chemical engineers can actively taking part for the reduction or remediation of pharmaceuticals drugs from the wastewater, even other contaminants from the wastewater by ozonation process and other advanced oxidation processes. David Gozer, a chemical engineer, managed the disposing of bauxite residue wastes from the aluminium manufacturing processes, which are in the form of caustic colloidal suspension, which is known as that red mud. Now this Bajar, you'll see that he used the suspension to make valuable material for the treatment of wastewater for use and reducing the volume of waste by a factor of 2. Later on, chemical engineers think about the process intensification based on the nanotechnology, and main scientific interest was grown to the exploitation of chemical processes with the length scales of the order of 100 nanometers or less, since the early 1990s. A small number of molecules can have very different physical and chemical properties from that molar quantities of the same material. Yeah, Aman, yeah, I agree with you that there is a that uh, uh, interesting fields for the research for chemical engineers in the field of batteries like sodium ion battery. It is already being done by different chemical engineers. It has huge application, and nowadays research interest is mainly on the energy production and energy that saving. So this batteries that synthesis of nanoparticles to give the long life of the battery, as well as that design of the battery in such way that other like that high pressure system or low pressure system, they are by changing the chemical properties, they are, and also the ionic properties of the chemicals, they are synthesizing different chemicals to produce that long lived battery system. So in that case, in the battery, in the field of battery, the chemical engineering research is going on. You will see that in IIT Delhi, there Professor Anil Verma, he's is doing intensive research on this energy system, fuel, even battery systems there. Professor Anil Verma in Chemical Engineering Department, IIT Delhi. So he has a lot of contribution in that case. In future also you can do a research under him also. Not only that, in your in this area you can do a research. After finishing this chemical engineering basic course there, you can start your career there also. Okay. So what I actually discussed that this role in nanotechnology, the catalytic properties of materials and in interfacial phenomena between unlike materials are nowadays is determined at the nanoscale. Achha. Yes, will to suggest what is that, Aman? You are asking that will to suggest any basic course I should study as I want to work in that field as I am BTech mechanical. Yes, you have to do some basic chemistry subject like electrochemistry. You have to learn, because in battery field that electrochemistry is very one of the important subject that without knowing that basic electrochemistry you will not be able to know in depth of this battery system. So I suggest you to do the basic course on electrochemistry. Okay, fine. And then yeah, so chemical engineer Michael Strano used carbon nanotubes to create nano channel based sensor to detect very low levels of impurities such as arsenic in drinking water. So chemical engineer play a vital role in environmental engineering and controlling that environmental pollution. And then chemical engineer David, you'll see that Schoen invented and commercialized the nano KRTM process, in which cotton fibers are wet with an aqueous suspension of carbon nano whiskers that are between 1 and 10 nanometer in length. It causes liquids to bead up instead of spreading. Now, role in polymeric materials, you'll see that chemical engineers play a significant role to derive the synthetic polymer industry, development of new materials, and their processing to make useful objects for society. You know that Gore-Tex is one of the that famous industry where uh, you will see that the chemical engineers, the Robert Gore, you will see that he has developed a porous film which is made from polytetrafluoroethylene, or it is named as PTFE, and this is basically used nowadays as a that Teflon. So the film is widely used in outdoor wear, but it also has found a medical application as synthetic blood vessels. So this that Robert Gore, she has contributed a lot in this field as a chemical engineer. And the chemical engineer, you will see the Frank Bates and Glenn Fredrickson developed a new transparent plastic polycyclohexylethylene. Actually, these are used in optical storage media to convert a brittle glassy material into a tough thermoplastic which is suitable for that disc manufacture. So their contribution as a chemical engineer is commendable. Now, role in that colloid science there, Alice Gust, she is also chemical engineer. Okay, so she discovered the it is called rheology, electrorheology. You will see that whenever ionic substances in a solution will be coagulating to each other, you will see the solution characteristics like physical properties will be changing. This is basically the phenomena of the viscosity of the suspension of colloidal particles that contains permanent dipoles which increases by order of magnitude upon application of an electric field. So she has given fantastic formulation for this colloidal science named as electrorheology, where that physical properties of the solution, basically viscosity of that suspension of colloidal particles, how it will be changing. And then role in tissue engineering also there. Christy Ansett name is that coming into the picture because that Christy Ansett, she is a professor of chemical engineering in Harvard Medical Institute there, and he actually did a lot of research on this tissue engineering, which is referred as restoring or replacing organ functions, typically by constructing biocompatible scaffolding on cells which can grow and differentiate. So in that case, in Harvard Medical Institute developed an injectable and biodegradable scaffold to support cartridge that or you can say that the cells as they grow for regenerated regenerate it is called diseases or damaged eat tissue there. So in that tissue engineering cases, this chemical engineer, how they can act a vital role there. It is there. So you can say that chemical engineers not only developing the process there, they are acting in different aspects. They're in the medical science, how to synthesize different medical medicine or drugs. They are even how they are producing that or designing that microreactors based on which that synthesis will be in a nano scale. Even there are different other process systems like in environmental systems. They are also acting a vital role there. And Membrane-based separation process is also one of the important, chemical engineering process, which are used in variety of applications such as, hemodialysis in medical science, and oxygen enrichment, development of the reverse osmosis process for water purification, especially for water desalination process. So in this regard, chemical engineers, like two names are actually important here in this case. They are the Sydney Loeb and Srinivasa Shauri Rajan. They are famous for their development of reverse osmosis process in 1959. Other that field like alternative energy sources, how it can be managed to give that daily life energy uses from the nature, like that non-renewable energy source to the renewable energy conversion. And their solar energy for electricity production is one of the area in which the chemical engineering role is remarkable there. In that case, I think Fraser Russell, he's one of the pioneer engineer. You can say that, or you can say that he's a leader to motivate a research and development team for the continuous production of solar cells, and designed a reactor that deposited to the semiconductor continuously on a moving substances. And other like chemical engineers are playing an increasingly important role in modern biology and biomedicine. In that case, yeah, Professor Arup Kumar Chakravarti and Dr. What is his name? That is Dr. Jain, Professor of radiation oncology, and Director of the Edwin Still Laboratory for Tumor Biology and Harvard Medical School, at Harvard Medical School there. So they are also chemical engineer, but they are working in the in this medical science. Chemical engineers also can play a role in public service, like administrator of Environmental Protection Agency, even evaluator of process for destroying stores of armed weapons loaded with different agents. So these are the roles, other professions in to study medicine, to study law, especially patent law, to enter the financial sector, which has been a large employer. So chemical engineer also can have their career in those fields there. There are several options are open for chemical engineers. So you have asked that to discuss that chemical engineering career where you can work there as a chemical engineer. There are several options open where you can work there. Okay. So anyway, go through the lecture notes. If you have any doubt anywhere, please write to me. I will clarify the queries there. So I wish all the best for your remaining lecture, whatever test you are doing there, and try to do your assignment work regularly and submit that assignment. That those assignments actually made from that lecture notes itself. If you understand, you can easily answer those assignment. Okay. So thank you for your attention for this live session. Thank you.